Good afternoon, everyone. God, that's very loud. Hope you're having a great time at KubeCon this week. My name's Phil, and welcome to today's Working Code Wins. Today, we're going to show you how I've used some technology in the open source space to transform how we've done hackathons at the Access Group. I am pleased to be joined by Abby.
Hi, everyone. I'm Abby Bangser. I have been working on internal tooling basically my entire career across a lot of different titles. Started as QA, DevOps, SRE, platform engineer, but basically my entire career has been how to help my colleagues. Now, and throughout that as well, a big part of my technology journey has been about being in the community. So I'm a CNCF ambassador, team topologies advocate, and just general enthusiast of just meeting people, getting to know people. So come chat with me about things. And Phill put up his mantra, and I swore I'd come up with something witty before
Well, you're going to have to come up with something on the spot. You've got a minute while I do my intro, and I think about it, and you can get back to you if you want.
Deal.
Right. So I love that you think about the experience, because the DevX for me is really, really important. So today we'll show you that whole DevX as well. And I love all things automation. I like automating as much as my life. My robot Hoover turns on when I leave the house. And things can get quite complex in software engineering, right? So my mantra, I'm going to put you on the spot, Abby, is there's no right or wrong way, but there's always a better way. And it's true when we think about our abstractions and when we go more and more into what the technology we're looking at today to keep that in mind. Enough time for you to think about a mantra?
I don't know if it's a mantra. This is what I was gonna write on it. Was I always believe you should be known for what you stand for, not against. So especially in the world of the CNCF and all the projects and all the technologies, instead of talking about which ones you don't like, spend your time finding the people here during this conference who are interested in the ones you do like, and go focus on that.
Oh, that's beautiful. And I found a few that I like today, and I've learned a lot. So the Access Group, who are we? What are we? We are the UK's largest headquartered software company. If you took a tube today to get to the event, you've used our software. If you've gone to Nando's recently, you've used our software. If you've ordered something online, chances are you've used our software through the chain. We are everywhere. We process around 2 million payroll records every year through our payroll bureau. And the list can go on and on and on. And I could talk about it, but we're here to hack, right?
Heck yes. Let's get hands on keyboards.
Let's just get on with it, yeah? So if you can all scan the QR code, or if you're brave, use the bit.ly link. I do recommend that it is case sensitive. And we'll get started with today's hack.
Absolutely. So as you're loading that up, one of the things that's key about something like a hackathon is that it takes a lot of energy to make it work right. If you've ever done like a bug bash or a hackathon, it can be quite stressful. But this guy just eats stress for breakfast, because this is what he was doing when he ran the hackathon that he did for TAG.
Oh, yeah, absolutely. And if I can make you all look like this when you run a hackathon, then I've won. So this is a picture of me during a hackathon, enjoying a large bottle of rum, and watching pipelines kick off like a madman in the Caribbean. So it does work, and I trust the platform and my team.
All right, so I hope everybody has found their way into Instruct. And what we're gonna do now is switch, and you would have found a screen like this. If you haven't already been the curious person that I'm sure you all are, please hit the start button. And that's going to start up a screen that looks like this. And we've done some pre-warming a machine, so I'm hoping that this will be quite quick, and it was. You'll see a kind of pulsating start button in the bottom right corner. I know that some of you don't have laptops today. That's OK. We're going to run through the workshop in such a way that we're going to do everything on the screen as well, but we're going to give some time for like self-study, essentially, to read the text, to explore the virtual machine, and all of that. So we'll make it clear when that time is on. Feel free to zone out if you don't have a laptop or research things. And then we'll show everything on the screen, so you won't miss anything of the workshop. So if you press start here, which I'm sure most of you have already jumped past me, this first screen is really just here to teach you about how to use Instruct. We're really grateful that they've donated their time, the virtual machines, to us to be able to make sure it works on conference Wi-Fi. Let's go. And it's a great program that's letting us have the instructions on the right-hand side, where you can open and close your instructions like this. And you can see the images kind of bigger and smaller as well. And then on the left-hand side, there's a whole bunch of tabs you can go through. And this first kind of section, including giving us feedback on each step if you want, not required, but optional. This first one is just learning about what's running on this virtual machine and how to use Instruct. It's very quick. Feel free when you're ready to click the check button, and that will take you through to the first proper task. And this task is to get started with your platform service, your first service you're going to deliver as a platform. I'm not going to talk to you all about theory right now because we're here to do a workshop, but we are going to talk about why we're doing this once you've gotten hands-on. So feel free to press start and continue on with this. So I'm going to stop speaking now and let everyone get busy, but what you're going to be doing is going through the providing a platform service task, and if you click the check button and you come up with this error of not quite right, try again because you're going too fast, that's a good thing. We're going to keep everyone on the same pace, so we're going to give you a password to be able to go to the next section when we're ready to. All right, so this will mean you're done, and you can just sort of explore around the virtual machine or wait for the time to time out. Does that make sense? Is everyone happy to do that? We're going to be walking around to answer questions as well as you go, so any questions about platform engineering, the workshop, Instruct, anything, feel free to give us a question. Raise a hand. All right? Cool. We're also going to start some music in a minute. I can press the play button here. If anyone feels like it's either too loud or not right and it's affecting their ability to do the workshop, please also raise your hand and let us know. We're happy to change that or remove it. But we just thought it makes it clear that it's kind of study time. It might be a bit more fun, a bit more like a cafe. So go ahead and get going if you want. All right, so it's not a live demo / workshop if something doesn't go wrong. So if you were hitting a track limit, we've fixed that. So go ahead and do a refresh or try it again, and it should work for you. So alert us if it's not now. I've just tested it locally. So cool, we've got at least one thumbs up, which is good. So here we go. So we've got just under 30 seconds to go, but I know we had a bit of snafus there. Does anyone want more time? Feel free to raise your hand and let us know, else we'll go with the demo side of things. All right. We're getting a countdown here. Banging on the table. 10, 9. I feel like the sound guys are going to start actually doing that the next time I say it, and it's going to be really awkward. Okay, so I hope you all had a bit of fun. I understand we just threw you into the deep end there. We didn't explain anything about anything. So if you're new to Kubernetes, if you're new to Cradix, if you're new to platform engineering, there's probably a lot to think about. So I'm going to go through this now myself, talking through some of the things that are going on, and then talk through some of the theory about why we're doing this. Feel free to raise your hand and ask questions during this. This is like, we're a nice small crew. Let's take advantage of that and actually talk it out. There is a microphone, but I'm very happy to repeat the question as long as I can hear it. So feel free to just shout it out to me, and that'll be okay as well. So what we were doing here is we were building the start of a platform. And what a platform is it provides something as a service. And those services can be things that you have to build yourself, but often there's things that already exist in the marketplace around you, the world around you. Could be a SaaS product you depend on, like GitHub, as the way that you host your software or your code base. They could also just be other templates and packaging tools, so Helm charts you depend on from the community. In this case, we used a promise from the community that does Postgres as a service. And what that did is it installs a promise. Promises are the definition of something as a service. So what we're doing is we're building a platform here. We're not being handed one. So unlike a PaaS platform as a service solution, such as Heroku or Cloud Foundry or those kinds, installing something like Cradix does not get you a platform. It gets you the ability to create one. And that promise packages up all the moving parts of providing an API with a server behind it and provides that simply. So you install that promise into Cradix. It creates a user-facing API for you as defined by you with your constraints, your requirements. And it sets up your environment to start serving those requests. In this case, we're living in a Kubernetes world, which means we need an operator to be able to generate the resources for Postgres. So We then go through and we actually look at the promise itself. So we know that promises provide something as a service. How does it do it? The way it does it is you define an API, which is the contract you have with your users. What are they allowed to tell you as parameters? What do they have to tell you? Within what constraints are they allowed to request things? That API exists. When the user makes a request through that API, you have to do business process things to make that happen. You might need to do security checks and authorization and authentication. You might need to do costing checks and make sure no one's going to run up a crazy bill, security scans. You might need manual sign-offs for certain activities to be okayed. Those all happen in a workflow. You also may even choose to deploy things as a part of that workflow using commands like the AWS CLI or kubectl CLI. But you may also choose to use declarative code and use the GitOps mentality. And we would advocate that, here at KubeCon, we would advocate that the GitOps mentality provides a lot of benefits, and we can talk more about that. I think we will a little bit later.
Definitely.
But if you choose to use that, Craddock's framework has a convention of helping you make sure that the declarative code gets to the right repository in the right place so that it can get deployed to the right infrastructure. So that workflow results in some code, declarative code, that goes into, in this case, Git, so a Git server. And then the dependencies had already existed in there and setting things up. So if we go through and we look at the next command, this is that diagram, but in Kubernetes. So the promise is a custom resource definition in Kubernetes, and it has these different fields, including the API field, where you're defining a CRD, and the workflows field, and the destination selectors field, which is how you tell it where, I realize that's probably small and overhead, isn't it? That's better probably. Where you define where it goes in your Git state store. You can check out the entire promise if you were to do a kubectl get and through to YAML, and you can see things like statuses. This is just like any other Kubernetes resource, built in or custom, right? You have that ability to explore it. So the API itself is a CRD, and so if I use the Kubernetes command to list CRDs, we can see that now in that list of kind of public custom resource definitions that we depend on, we can see the Postgres one that we just created. We can also see that, and it's right there alongside all the other CRDs like Flux and Cert Manager that we depend on. We can see what fields the promise defined in that CRD by using the explain command. So this is the end user facing API for Postgres. We all know, having used databases before, there's a million flags you could set. But you may not want to provide all of those to the application developers because they may not understand them. They may not be allowed to use them based on your company policies and so on. So this is a very, very simplified API, and maybe too simple for some of your companies. But that's the things. It's completely up to you. You write your API the way that you want to. So fields are name, environment, namespace, and team ID. And then finally, what we did is we had a look at what happens to set up the environment. We talked about the fact that there's going to be an operator that needs to be managed. The way that it does that is we create this workflow object, which is, as you can see, just a job in Kubernetes. And that job runs a set of containers. So you can write your logic into any language you want. A lot of people start with Bash, but very quickly find that they prefer languages that are more testable. So we see things in Golang and Python and Elixir and so on. So really any language that you want to write a script in. And at the end of the day, those get written based on the destination selectors. So this first command is saying, hey, what did the promise define as the location for this, for these resources to be created? The promise said these should be created in a world that lives up to being environment dev. And then we said, okay, well, what worlds do we have? Where could this be scheduled? And it turns out we have two possible locations. One, the platform cluster, where Cradix and Git and Minio and all those tools are being run, and one being the worker cluster, which is where it's going to be scheduled to. So you can see this if you've used the labels and selectors idea in Kubernetes before. This is it, right? This is how we do pods with services and things like that. So then the last piece that you would have done is go into Git and actually see how that is in the it is done in the GitOps way. So you can see, so basically Cradix doesn't want to know how to get to any of your infrastructure, because we know that your infrastructure is not as, A, probably doesn't want us to know about it, permissions-wise, but B, it's not always going to be as simple as a Kubernetes cluster. It can be, we work on mainframes, we work with customers on mainframes, on edge compute nodes, really on networks, on anything. And so we want to be able to just write out to a Git repository and let the deployment techniques that you use on your environments work for you. So here we can see that those YAMLs have been written out, and we can see that those YAMLs are the ones that result in the Postgres operator successfully deploying out to the worker cluster. And we do that through Flux GitOps. So at the end of this, we have a situation where an application engineer would be able to come to Cradix, come to your platform, request a database, and be able to see it. But what we're going to be building towards is them being able to do that for an entire application, so a web app that's backed by Postgres database. And with that, you all get unlocked, which is probably what you all are waiting for. Oh, sorry. I'm going to talk a little bit, just a quick minute about the theory behind this. So the reason why this is an important kind of step when building your platforms is because platform engineering is intentionally centralizing operations again, which sounds really counterintuitive if you've been through the DevOps wall to DevOps transformation over the last kind of decade or so. But the re-centralization is giving access to more security and more support. And so what we need to talk about is the fact that we got a lot of benefits of reduced delays and increased autonomy from DevOps. And we don't want to lose that with this re-centralization, even if we want to improve on our kind of centralized management, the ability to get like economies of scale within our organization and so forth. And so with that re-centralization, we need to think about how to service the teams in a way that is sustainable. And that means that we have to build as-a-service platforms, rather than having requests come in through tickets and lots of manual processes, or even automated processes that depend on a person to pick them up. So we want to centralize without delays. We want that autonomy, but with safety built in and guardrails in place. And we want maintenance that allows us to manage things efficiently. And we're going to look at each of these in practice over the rest of the workshop, basically.
Yeah, and there's a lot to take in with all the different moving parts, but what we've just shown is how to get your dependencies on a cluster. And this is just for a hackathon with the Postgres, but I do this with all of my other operators. So Portworx, Cert Manager, everything I customize and I do via promises. So it's a lot of moving parts, but yeah, we'll go through it and you'll see more and more as we explore.
Yeah, it'll get fun. It'll get bigger and funner. So the way that it works is if you create a file by the name AAS, or as a service, you will be unlocked to click the check button again. If you haven't fooled around on your VM, you can just create the file in your current directory in the terminal using the command touch. If you have fooled around and gone elsewhere in your terminal, make sure you use the complete command to make sure it gets placed into the correct location. All right? So with that command, you should be unlocked to go through to the next section, and the same process will repeat. We'll set the timer, we'll let you all go and get going on it, answer any questions walking around, and then we'll talk through what you've done. Any questions before we get going with that? All right, well then I'm gonna set the timer and go.
All right, well, we'll get cracking. So far what you've seen is you've created a Postgres operator, you've set where that is, and now you've gone through the process of requesting a resource. You've got this, so I'll go through the commands here. I will have to create the file. Thank you very, very, very much. So when we have this promise, where you've seen the API, you've got the name, the environment, and the other variables you've got set there, and you've been able to request a resource. So let's go have a check on that promise. It's definitely there. And we're going to go apply this dev database with a team name ACID and the DB name set. That's gone through the resource configure pipeline, taken the information that you've provided in the API, and set all the complex stuff on behind the scenes. It allows us as platform engineers to decide what we want to give to our users. Hopefully your pods will now spin up and you can see that the workflow is executed. And the actual database itself should be running on your worker, quite happy to go. Now, I was learning Kubernetes as I go. I was doing this on hard mode. GitOps, Kratix, plus Kubernetes, and now I can create databases and teams only need to give me a full few bits of information. At this point, that's where I fell in love. I know I could go create 100 databases, give me a seg command, and I'm a madman. Try it at home. So this really helps by giving you the flexibility to say, hey, you can now provide things on your platform without having to rewrite the rule book when new requirements come along. So you could change the dev to a prod tag, and we'll look at that later on and see how that changes in the platform API. So you get to really decide your level of control, right? This is what we're talking about. What is important for your users? Do you want your users to have the full customization of the operator you've chosen, where they could break things, change things, and have that complexity? Or do you want it really easy to start with no configurability like we've done with a Postgres operator? You can make those decisions for your engineers and codify them within your promise. As you see in the Postgres promise, by changing that dev to prod, we're going to do the backups, right? We're going to make sure there's enough replicas for your application, ensure that follows our operator that we've decided on, because I'm pretty sure no one wants to run in production without a backup, right?
Right, and we test our backups, right?
Yes, we do test our backups. So as we're ready to move on to the next section, do a touch on -demand, and we'll start the timer again and go on.
What we were just doing is looking at the fact that the reality is platforms are just software now when you think about things being as a service. And with software, we've had decades of learning that the three little bears simplify things. Too big, too small, just right is not as easy as it sounds. And trying to figure out what size a service should be, micro, mono, whatever, is difficult. And so the reality is that we need to be able to compose and decompose the decisions that we've made into the platform service. So this is showing composition, so taking smaller pieces and making it bigger into something that is more powerful. So a database plus a web service together making an application combination. So with the app as a service, the idea here is that you have a promise that orchestrates multiple other things. So we're not recreating Postgres here. We are reusing the Postgres promise by having the app higher level promise make a request to it. There we go. And so what we can do is we can see in the editor that the app as a service promise, this app promise, has a set of required promises that are on lines 62 to 66. So in order for the app promise to succeed, to do its job, it depends on Postgres and Nginx. Cool, that's fine. That is something that we can make sure the platform has set up. We can also see that we use the magic of instruct here to pre-install that for you. So you had previously created the Postgres in the last section. We then installed the app as a service promise and brought with it the Nginx. So we now have this situation where we have 3 promises. And we can see that they're of slightly different shapes. Like one doesn't have it, Nginx doesn't allow user requests. That's okay, because you're gonna have oddly shaped things in your platform and you need to be able to manage them. So now that we want to build the application, we want to actually make a request for a to-do app. And this to-do app is the same as any kind of application developer in your organization wanting to just write their code, package it up, and be done with it, and see it go out to end users. In this case, we're asking them to tell us the name of their application, the image they want to run, whether or not they want a database, and if so, what type, and what port we need to expose for that service. Again, keeping it kind of simple. So with that request, we are going to see that a couple of tasks run. So if I do the next command first, let's do this. So if I see this pod, we'll see that it is currently initializing. So I'm going to put that on a watch command quickly. Oh, it's already completed. All right, well, I missed it. But if you saw it, you will have seen that it went through a few different steps, a few different init containers. Basically, the framework behind the platform building starts with giving you, as the promise author, access to the resource that triggered the workflow. So Cradix runs a container that goes and gets that resource and places it on your file system. You then can do as many tasks as you want in the middle. In this case, we're managing the resource and the database. And then Cradix also, as a framework, provides the tasks at the end. So it takes the documents you write onto your file system and it writes them out to a state store, status, etc. So we can, with that having been done, we can see now that you have a built-in catalog because Kubernetes. This isn't a Cradix thing, this is a Kubernetes thing. You're making your requests on here, you can list them. And when you're done with your, once that's been deployed, it tells you where you can go get to the website, and we actually have that being exposed on Instruct. So you can see that website running. And yeah, and so you can see also how you can customize the information that goes back to the user. So what we have now is a promise which wires together a few different things, including, if I go to the actual scripts that we're running inside of that workflow, we can see that the database is taking information from the application in order to make its information. So it's basically saying, let me get the database information and add that to the application so it can wire together. In a piecemeal solution, you'd have users having to create a database and then kind of walk their permissions over to another location to create their web server. In this, because of the composition, you can get that done all together.
Yeah, and that's the real power, right? We've made the decision to use Zalando so we can follow their patterns, and it's an internal platform, and we've just codified that experience here to make it easier for engineers to just have an app with a database.
There you go. And so, yeah, and then this command here is just showing how, at the end of the day, all that it did was make a request to the same Postgres promise that you had originally made a request to in the last section. And you now have your application. So why are we doing this? It's because of that monolith microservice aspect. Platforms have to start thinking about their architecture. They have to start thinking about what should be changed together, what is the blast radius of the changes they want to do. But the good thing is you don't have to start from scratch. Lean on the existing architectural conversations around software to build that platform right. And some tests for whether or not you're building your platform with the right foundations is whether or not you can introduce a new sort of paved path or like best practice within your organization without having to kind of copy paste or rebuild from scratch. You should be able to build off of the pieces that you have and compose and decompose and recompose them, because you need that flexibility, and you need to be able to also make sure that people who are not eligible to use the entire package you want to deliver. So they can't use the whole app as a service, can still have standardization for things like the database by itself. And that's sort of that composition aspect. And so the QR code here is for the Gregor Hope article about fruit basket and fruit salad. It's just, if you haven't checked out his book, it's really good on a lot of these topics. But again, we're here to be hands-on. So if you go ahead and touch the file compose, create the file compose, you can get started as like what we just did. You can get started on the next section where you're going to be turning your internal platform properly internal and moving away from the marketplace, but doing other things. Cool. Keep walking around answering questions. Please keep asking. It's been really good questions. This is like the real power of being in the room together. So please keep talking to us.
Okay, everyone, thank you. So that's that timer up. Does anyone need a few more seconds or got any questions? Excellent. So all you've got so far is you've configured the app as a service to accept environment variables. So let's go through that together. We've updated the promise, right? So we've got our promise API extended and to include the environment variables. So if I just pop that in here, that's updated our promise specification, which if we go to our editor, refresh our files, we should see beautifully here, there's our environment API. Let's go ahead and apply that to the cluster, so that will update the promise. And the cool thing that we're going to learn later on about Kratix is that all previous resource requests will be updated with that new promise. It will replay itself. So you don't need to do anything. And we can just double check and make sure that's there. And we've got our environment. So let's go use it. Hopefully you've got your to-do app already there, and we're going to just set a random number, 1.21. And what this has gone and done is exactly what we were doing before. It's taken that project, going through the API specification, and it's running this script here. Scripts, environment vars configure. It's just loading up the YAML file, understanding what the inputs for the user are, and generates a config map for us that attaches it to the container. As Abby mentioned before, Kratix pipelines work by putting in some magic in certain file structures, Kratix /input/output, and the order of the pipelines matter. Because we've put the environment variables like sandwiched in the middle or at the end, we can pick the other files that have been executed before and mutate them. So when we go check Gitty, we can go into our worker cluster, our resources, in for our to-do app, and that should hopefully have our thing. I probably haven't run it, have I? I haven't updated my workflow. That's what's happened. So let's update the workflow.
That's why packaging things together helps, rather than
helps.
having to do it in 3 different systems.
So now I've replaced that promise, that workflow step in, right? So I'll put it at the end. Let's go tell their promise to say, go do that for me, please. Let's check if that's gone through okay. We've got more pods to go through, and that's completed. So now if I go into Gitty and go into my resource, hey, there's my config map with my version. It's almost like it happened like a professional.
There was no sweating here.
No sweating at all. Nothing.
Live demos, it's all good.
And feel free to have an explore with the enterprise environment var, right? We have an enterprise version now to do app because why not? Now, you might be thinking, great, app as a service, what can you do with that? Well, in fact, we ran our Backstage instance for the hack using that app as a service promise. So it has a Postgres database. We configure the app config. So all the users that were using the platform were using a service that we were using ourselves. We really wanted to eat our dog food and test the resilience of it. We had over 250 projects, supported 3 different hacks across the organization, not only just in products and engineering, but professional services and other people getting involved into our hacks. But we also customize the promise a lot. The promise you see sets up an ingress, but we wanted to do Let's SSL certificates, give everyone that full, nice experience when they get their application. It's all secure and they can use anything on their APIs. So let's get into the next section, how we're going to turn that in a little bit further. So if we do a touch bespoke, we can get into the next steps.
All right, so we just got to make, they say, you know, make something work and then make it pretty, right? So we had our APIs all working, we got the business logic all settled, and then it was important to think about what do our users want. So here we are, putting some icing on that cake and creating a Backstage Portal front end for the APIs that we've been creating for the app as a service. So with Backstage, it's also a framework, so it has a lot of the same principles that Cradix has, in that you don't just get a portal when you get it, you get a framework for building one, and you can lean on the community to get started quickly, but you also get to customize it to your own liking. So we did pretty minimal customization, to be clear, because this is a hackathon and a workshop. And so we just started with like a guest entry, and you can see it's an empty Backstage when you get started. We've got nothing in it. Traditionally, what you would do here is you'd start to codify what you want to expose in Backstage as YAMLs or as JavaScript, and you'd be pulling these in as plugins. But then you're all of a sudden managing your business logic in the user interface layer and in the API layer and in any other user interface you might have, for example, a CLI or a chat bot or otherwise. So what we're going to do here is we're actually going to teach Backstage about how to access the APIs that you've created in Cradix. And we do that by having it read Backstage-generated YAMLs from Minio. Minio is a storage system that mimics S3. So you could be doing this in a more kind of permanent storage S3 bucket as well, or a GCS bucket if you're in Google. And so what we do here is we add yet another workflow. That's going to become an acronym, I just know it. Yet another workflow action. This time, it's going to be taking the API from the promise and translating that into a Backstage-shaped YAML. It's also going to write that now Backstage-shaped YAML into the state store, but it's going to write it into a location that Backstage reads from. So in this case, Minio instead of Git T. And this is how you can mix and match your state stores as you need to. So with that promise updated, we can run it, and similar to the last one, it will just start to run the workflows. And we can see those kind of running through and initializing. So it runs both the promise underlaying level, and then it runs through for each resource in order to make sure that everything gets kept in sync. So this is what you're going to get into more in the next section, which is fleet management. With that, Backstage now has the ability to create apps. And we know that, I should have shown on the homepage, because we now have components that have been loaded in. So we have the app promise, we have the to-doer app, and we have the ability to use the scaffolding template section to create the app. But instead of using a typical scaffolder, which makes API calls out to specific products, this is going to make an API call to Cradix, which is going to keep everything inside your API, inside your platform. So I can choose this, I can call this KubeCon, I can then not try and remember the name of the app I was going to deploy, and then database or otherwise. So you can use really nice, this is all codified in the workflow to say, hey, make that a drop down. Don't make them type that in, you know? And set the service port, review, and create. That, as I said, is going to make a request out to the Kubernetes cluster. And so now if I go and I get apps, I can see that the KubeCon app has already been completed. But to show you it wasn't just a fake out, K is short for kubectl. I can get pods, and I can see that the KubeCon pod here was run 22 seconds ago. It's just when you don't have a human in the loop, things happen quickly. So with that, we were able to get that app, and we were able to see that now we can treat an application in your organization the same, whether it gets created by a GUI, a CLI, GitOps, or still through a ticketing system in some way. We have people automating, Jira tickets into requests to the platform. So wherever the requests are coming in from, you can meet your customers where they are, your app developers where they are, and they can, but then still be all a part of the platform.
Yeah, my first request when I got this promise out to people was, hey, I don't use Postgres. Can I have Mongo, please? And I just extended the promise, and we went through this workflow, and they could see Mongo and carry on. So it turns into a living, breathing platform that you can adapt over time.
I lived that life of everyone wants Mongo. I lived that life.
Give me a graph.
Yeah. Until I need to change my schema. Then can I go back, please? Okay, cool. So with that, I just want to talk for a minute around the fact of the value of having a platform API. So you can say, Abby, you're obviously talking about platform APIs because you help build Cradix, and that creates APIs. Get off the stage. And I get that. But what I would call attention to is just software engineering in general, right? With an API, if you've lived through the era of moving from like web apps to mobile apps, you will have lived through the era of having to take all the business logic from the display layer of a web app and having to figure out how to duplicate that, triplicate that across the different mobile platforms and so forth, and realizing, no, I don't want to have to worry about logic in multiple places. I want logic in one place, and I want to worry about display and only display in those interfaces. So when we think about how our users use our platform, we realize that there are a lot of different needs and a lot of different users. They're not all app devs. Sometimes they're managers, sometimes they're product owners, sometimes they're support engineers that may use different interfaces. So you need to think about that autonomy, the distance from where people are working and whether or not you want to meet them where they work, how much skill they need in the capability they're working with and the interface they're working with, and therefore meet them where they are. And this QR code goes to a talk that I gave with Whitney Lee at Platform Engineering Day in Paris last year, where we talked about the fact that you can think about the API as the pig, and the interfaces as putting some lipstick on to dress it up. So people going straight to the API isn't that pretty, and we know that, but we want to see people get better experiences. So please add as many lipsticks as you can to these APIs and make sure that you meet your customers where they are. So speaking of, we really liked API pig, API pig. It was good. It was a GIF last year. I don't have the GIF. It's gone. Okay. All right. So, but with that in mind, the password to get to the next section where we're going to actually look at managing the 2 apps that we now have and maybe a few more is API pig, a pig. So go ahead and jump into fleet management. And that is, just to be clear, the last of the major meat of the workshop. And then it kind of goes into just a playground mode if we have a bit of extra time. So we're getting through. Keep asking questions. It's been really lovely chatting with everybody. All right, so I stopped looking at the clock on the last section. We are actually done in 5 minutes. So what we're going to do, so feel free to keep having a look at this. The boxes will stay alive, so you don't have to type furiously right now. But we are going to go through just a bit of the wrap up because Phil's got some awesome stuff around how he went further with the hackathons, and I think it's worth sharing that before we all disappear. So, oops, sorry about that. Yeah.
So yeah, as I mentioned, I was learning Kubernetes, platform engineering, everything in one hard go. And I'm also a GUI person. I like an interface, so I am that pig with the lipstick walking around the office. I push that button. Don't push that button if you don't know what you're doing. And I did that the day before the hackathon. All the resources, my Backstage instance disappeared, and mild panic ensued. Thankfully, and Abby did ping this up earlier, oh, do you do backups, Phill? Thankfully, my friend Andre was like, Phill, please can you take a backup of the database? Please can you take a backup of the database? And I did, and I still thank him to this day, because I took that backup, I stored it on my desktop somewhere, And then when this blew up, I was like, oh God, I've lost everyone's data. Because within our platform, we were giving the way of people to manage their teams. Say, hey, I'm part of this hack team, I'm part of that hack team. A quick little call to Syntasso, a little Slack message going, guys, something's blown up, what do I do? And Derek and Colin both turned up and was like, yeah, you've just deleted that, just put that in. And that's when I learned GitOps. It made me feel a little bit like a god, because believe it or not, I only learned Terraform 4 or 5 years ago, and I felt like a god turning things off and bringing them back alive. But we actually now are thinking about using this GitOps pattern about a disaster recovery. What happens if someone goes and destroys the cluster, or a data center burns down? What do we do? Well, if our state's declaratively stored somewhere else, we build the promises and the APIs to decide, well, how do we transition?
And because Kratix runs the workflows in Kubernetes, which has a reconcile loop, you actually don't even have to have declarative code to get fleet management and to get that safety. Because as long as your workflow redeploys things, that's what it's going to do. So you get that sort of reconciliation and recovery built in because of Kubernetes. So very, very glad to be building on top of that.
Yeah. So please have a look through that fleet management section. And we've looked at replicas, but I used it for everything. Continuous changes of my promise and updating it. So in conclusion, the hack architecture actually looked a little bit like this. We had Backstage use Backstage templates to pull an Azure pipeline as a base template, replace all the variables, push that out into a repository which would execute a pipeline. Now that pipeline will build and push to the container registry, but also do a kubectl apply with the app as a service promise. Then the rest is up to Kratix. Kratix will go schedule the request and put that out there. Now, I was learning, so this is just as a hack for me as it is for everyone else. So I installed a hack called KillSH. It's an open source tool which I could just set a webhook from my container registry, and it would just update the image for me. So I didn't have to tell teams, hey, for a hack, you need to follow this GitOps flow, or you need to use trunk-based deployments. It's like, no, just push it all up. I'll just take the latest image, and we'll deal with it. If you want to see a little bit more about how I got that working, come reach out. I'll show you a little bit more.
You can't get Phill out of an IDE, so seriously go chat if you want to see anything in what he's been up to.
And I couldn't do all of this without my team, right? So I had some fantastic people that worked with me. Adam Lonsdale, fantastic engineer I work with. Andre, my backup god. And all these people here have helped me in various ways to bring the platform and hackathons to life at Access. So I couldn't do that without them. Thank you. And also thank you to everyone at Syntasso, because I give them feature requests, and I can call them up, and they're fantastic to work with.
Twitches his nose, you know? All right, cool. So yeah, just the quick wrap up. If you just go to the next one quickly. The hackathons were able to enable both Phill learning, platform engineering, and Kubernetes, as well as the application teams getting into Kubernetes and apps. The big thing here was that Phill was able to start quickly. I'm pretty sure he had the vast majority of his built in a weekend.
Yeah.
Definitely during working hours. But he was able to then maintain momentum because it was built in a sustainable way. And it came in layers. So none of this was possible without all of the tools that are here. So to be clear, this is not about like one tool solves all your world's problems. It's about having them interoperate correctly to be able to build for you a sustainable and maintainable and scalable solution. So if we go to the next slide, the password for the next one is called Fleet, so it shouldn't be too surprising for you. And you're welcome to click through to that. And if you have the time, one more slide, the CNCF tries to collect feedback around all the talks so that we can make sure you get the right talks on the stage. So please, good, bad, or ugly, we'd love to hear from you directly to us as well as to that QR code all about things. And if you do continue on to the next section, there's a bunch of links around how to get back to this. So you can share it with your colleagues, you can share it with your friends, you can just do it yourself when you're not in conference brain situations. And I realized that we don't have them on the slides, though I kept telling people it would. I will add a slide with that before uploading the deck, which I will do directly following this course. So if you look up the schedule for this class, for this workshop in like, I don't know, half an hour, you'll have all the slides and you'll also have the links on those slides to be able to get back to this. So come find us. I'm booth S641 if you want to chat with me further, and Phill is
floating around, but I'll come and play a game with you in a bit.
Oh yeah, we've got so if you liked the idea of building services, whether it's with Craddox or otherwise, I've got a card deck and game I'll be playing during the booth crawl that helps you think through how do you build a platform service. So come hang out. We've got, the drinks are on the CNCF, the game is on me. Come hang out by the tables over in the S corridor. So hope to see you there. Thanks all.
Thank you, everyone.